Welcome to this machine learning session. I'll be giving a brief introduction to machine learning and also be sharing some of the work I have done, and that's I built a face mask detection system. So after we've gone through the slides and gotten some little bit of introduction to machine learning, I'll be sharing with you the work I've done of the face mask detection system. So I'm Eric Odhiambo Uma. I'm a Microsoft Learn Student Ambassador at Kenyatta University. So maybe keep in touch. You can contact me on Twitter at _Eric Ouma. And yeah, let's go to the next slide. So one role we do have as engineers or software developers, or one goal that we usually have in science and technology is solving problems. And I want to believe most of you have interacted with programming before, or just basic mathematics. And so we have the sample problem here, finding the parity of these two numbers, 120 and 345. So parity is basically whether a number is odd or even. And so given this problem, first you need to understand what the problem is. The problem here is finding the parity of these numbers, which is either if the number is even or the number is odd. And after understanding the problem, the next thing you need to do is you think of the solution on how you can solve the problem. And I believe most of you know the solution here. Basically, you divide these numbers by 2, and the one that does not have, the one whose remainder is not 0 is the one that is an odd number, and the other one is an even number. And so doing that, we find this, and this is the simplest code I wrote that can solve that problem for us, identifying whether a number is either even or odd. So you divide the number by 2, and if its remainder is 0, that number is even, and if the remainder is not 0, that number is odd. And this is the traditional programming that most of us are used to in the software engineering world or software development. And so this brings us to the question, why machine learning when we have this very simple way or very common way of solving our problems? And now I give you this question. Ask yourself this question. Imagine you are a software developer, or you're a software engineer, and your boss has told you to build a software or a program that can distinguish these two images. So a program that when given an image with the face of a person, it can tell whether that person is wearing a mask or that person is not wearing a mask. And so I want you to think just for a few seconds on how you can build such a program, or you can write the code for such a program, putting in mind what we did here. So looking at this code here that was helping us identify whether a number is even or odd, now I want you to think of how you can write a program that can identify whether someone is wearing a mask or someone is not wearing a mask. And yeah, I believe you're already seeing how difficult that is. And I want you to see this from the point of view of computers, because for we humans, actually, you might not be appreciating it, but our brains are very, we have the best brains, because it's very, a human being looking at these images can quickly recognize that this person is not wearing a mask and this person is wearing a mask. But for the case of computers work with numbers. And so when you give a computer these images, what a computer sees are numbers, zeros and ones. And so you can try imagining how it might be difficult for a computer to be able to distinguish between these two images. And this brings us to the idea of machine learning and why it might be necessary, because there are some problems which are not very easy to solve with the common way or the traditional way of programming that we are used to. And maybe just to mention, you'll note that most of this talk is geared towards computer vision. That's image processing, image analysis, image detection, and image recognition, which is just part of machine learning or part of artificial intelligence, which is a very wide field. And now this brings us to a little bit of summary between these two areas, traditional programming and machine learning. So basically, in traditional programming, you define the problem and the solution, you develop the rules and logic, and then you refine until the the goals are met. So like in our case where I wanted to find out whether a number is odd or even, so you define the problem and the solution. So the problem is finding whether a number is odd or even, and the solution is dividing the number by 2 and using the remainder to identify whether it's odd or even. Then you develop the rules or logic, you write the pseudocode or the code, and then you refine until it's working perfectly. But in machine learning, you realize it has the same criteria. You define the problem and the solution, but here now we don't have this part of developing the rules and the logic, because I want you to imagine how you can be able to develop the rules and logic to distinguish between an image that has a mask and an image that does not have a mask. And so in machine learning, we use something called models. And so we train models using examples, and then we refine until goals are met. And this brings us to maybe a easy definition of machine learning. And I will define machine learning as an area of study or a field of study that deals with giving computers the ability to learn and solve problems without being explicitly programmed. So not the word explicitly programmed. So explicit programming is the programming whereby you give the exact rules or the specific rules that the computer is supposed to follow to solve a problem. But in machine learning, looking at those images that we are having, I want you to imagine what kind of rules you might be able to give to distinguish between an image that has a mask and an image that does not have a mask. Or imagine that you want to build a software that can distinguish between an apple and an orange. So you can see that it's very difficult to come up with the rules and logic for such a program. And that's why machine learning comes in very handy. So going to our next slide. And I believe most of us have interacted with these terms before: artificial intelligence, machine learning, and deep learning. So as you can see, artificial intelligence is what covers all this, and then machine learning is a subset of artificial intelligence, and we also have deep learning, which is a subset of machine learning. So basically, I'll define machine learning as giving computers or machines the ability to be intelligent, or making computers and machines intelligent. So artificial intelligence is very wide, and it covers very many areas such as computer vision, natural language processing. We also have robotics. We have autonomous cars. So artificial intelligence is very wide. And then we have machine learning, which is just but a subset of artificial intelligence, which I defined as the field of studies that deals with giving computers the ability to learn without being explicitly programmed. And then we have deep learning, which is a subset of machine learning. So basically, deep learning looks into now making machine learning better by trying to emulate how the brain works. So deep learning here is where maybe if you've heard the term neural networks. So here is the part of machine learning where we involve neural networks, and most of our talk will be the project that I'll be showcasing today is majorly I'll consider it a deep learning project, because it's all about neural networks, and I hope that's very clear, and you're able to distinguish between the three terms. And so types of machine learning. So on a general point of view, we have three types of machine learning. We have supervised learning, we have unsupervised learning, and we have reinforcement learning. So supervised learning, as you can see from the slide, so supervised learning, these are machine learning algorithms where you train them, you teach them how to do something. Then after teaching them how to do something, now you give them the problems to solve. So for instance, our program that is to distinguish two images, whether one has a mask and whether one does not have a mask. So you give a computer images of people wearing masks, and you give a computer images of people who are not wearing masks. So you train your model. We'll be discussing more about what a model is. So you train your model on with using these images, and from there now, your model, depending on how efficient you trained it, or how good your data was, it will be able now to distinguish when given two images. It's able to distinguish which one has a mask and which one does not have a mask. So maybe that's a use case of supervised learning. So we also have unsupervised learning. So unsupervised learning, as you can see from the slide, so it says it's self-sufficient in learning. So in unsupervised learning, what happens here is that you don't give the computer labels. So for instance, let's say you want to build a program that can distinguish between images wearing a mask and not wearing a mask. So in unsupervised learning, you don't label the images. You don't tell your computer that these are images that have mask and these are images that don't have mask. You just give it the images, and then from the unsupervised learning algorithms, your machine learning model should be able to distinguish or group into different clusters images that have mask and those that do not have mask. And reinforcement learning, just as it says, so my life, my rules. So it's hit and trial. So maybe I'll give you, maybe just to make this more, to bring this home. So reinforcement learning, consider reinforcement learning like training your dog how to do something. So it's based on rewards, and it's based on rewards. So when you're training your dog to do something, so when the dog does the right thing, you reward it. But when the dog does not do the right thing, you don't reward it. So reinforcement learning copies a similar pattern whereby you are using rewards to train a model to do something. So you just you put the model or the algorithm in a new environment, or an environment that it has an existing environment. Then as the machine learning models interact with the environment, now as it does trial and error, now when it does the right thing, it gets a reward, and when it does not do the right thing, it does not get a reward. And maybe most those of you have heard of AlphaGo. So AlphaGo was a machine learning model that was built by Google's DeepMind that beat the world's best Go player. And Go is a very difficult board game. You can go and do some research on YouTube. So Go is a board game with very many combinations, probably more than the atoms in the world, all the combinations of the board of the Go game. So reinforcement learning was also used in building a model that also beat the world's best chess player. That was developed by IBM some years back. And that's also in autonomous driving, self-driving cars. Those are some of the areas where reinforcement learning is used, and also in robotics. So the process of machine learning, as we'll be seeing. So in machine learning, the process that we do have here is gathering data. So the problem, for example, problem here are distinguishing images that have mask and those that do not have mask. So you gather the data, that's there. You gather the images of people who are wearing mask and the people who are not wearing mask. So you explore the data. So basically, you look at your data. If the images are the images that you want, if they're correct images, if they're well labeled, and you prepare the data. So in preparing the data here, and I'm sorry to say this, that this session is just a shallow introduction to machine learning. So there might be some concepts that I'll mention that are very deep, but we'll get to know them as time goes by. So in preparing data, in deep learning, in the neural networks, you don't just give them data to start working on. There's a format in which you must feed your data. For instance, let's say if it's images, there's a format that you must feed your data into the neural networks. So maybe if it should be an image of 150 by 150, that's height by width, and it should be having 3 channels, that is RGB, red, green, and blue. And so that's part of the data preparation, and we'll be looking at more activities that can happen in data preparation. And it's very important. These first 3 steps are very important: gathering your data, exploring, and preparing data. Because if your data is not correct, or if the data you are having has been interfered with, you'll not be able to build a very accurate machine learning model, because it will be misled. Because just imagine, like you're teaching a baby how to write. You're teaching a baby the alphabet, and then you teach the baby the wrong alphabet. So that's what the baby will learn, and so that's what the baby will do, because they didn't have prior information. And the same applies for machine learning. If you're having data that is not well curated, your machine learning model will not be able to perform as you are expecting. And then the next step that we have is building, training, and evaluating your model. So you build your model using some libraries, and then you train it, and then evaluating basically is finding out the performance of your model, how it's performing based on some parameters, which we'll talk about. Then next, we have a step called tuning hyperparameters. So when you build a machine learning model, for the first time, depending on your experience, it might not perform as you expect. And so with this, and you'll find that from model evaluation. So, and with that, you'll need to tune to tune your hyperparameters so as to improve the performance of your model. And we'll look more into how you can what can tell you that you should tune the parameters of your model, what can trigger you to do that. And then the next step is deploying your model. So deploying your model, now this is where now your model is pushed into a product and whereby it can be used by people. I believe most of you have smartphones which have face detection. Like I believe most of you have smartphones which you can either open it with the password, you can either open it with the fingerprint, or you can either open it with your face. So opening your smartphone with your face, that's an aspect of machine learning, computer vision. And so that's basically a machine learning model has been deployed to your computer, to your computer or to your phone, which is able to detect faces. And that's a quick overview of the process of machine learning. So what are some of the things machine learning can do, or what are some of the areas where machine learning is used? I believe all of you have email accounts, and maybe you've seen this feature of Gmail, probably where it's able to classify your emails into spam or not spam. So this is machine learning in action. This is machine learning in action, and its classification. It's under classification, and classification is under supervised learning that we mentioned earlier. So basically, when you're building your model here, you give it, you train it with emails which are considered spam and those which are not spam. And yeah, that's the classification model. So something else that machine learning can do is clustering. So imagine you have a social media platform and you need to run some ads, which is basically how most social media platforms do make money. So when you're having this social media platform with millions of people, you cannot, to be effective enough, you can't just run ads. You need to find out who should we show this ad, or who should we not show this ad. And when most people are joining the platform, you don't know what kind of post they are, you don't know what they like, you don't know what their interests are. And so clustering can come in handy. It can help you in grouping these people into clusters so that you can be able to have, so that you can be able to know how to run your ads effectively. When you have grouped these people based on various features that your machine learning model was able to detect. Another area where machine learning is used, we have linear regression here, and linear regression is also, clustering is under unsupervised machine learning, because you're giving your machine learning model unlabeled data. So let's say you want to run ads, the people are interested in computers, there's those who are interested in toys. So your machine learning model does not know that these people are interested in cars or toys. So based on the things that these people post, what they like, so it will be able to categorize them into people who like electronics or those who like toys. And so that's clustering, and that's unsupervised learning. Then we have linear regression. Linear regression falls under supervised learning, and maybe those of you who have done probability and statistic course, you have interacted with this. So linear regression basically deals with uh, continuous data. So as you can see here, we have a graph which is total miles driven again versus total paid for gas. And basically what we're trying to do here, this is basic math. So we have in the y-axis the total miles driven, and we have the total paid for gas. So let's say you're a vehicle, you're a driver, you own a logistics company or a vehicle company, and you need to find out how much people will pay for the services. So linear regression can come in handy in helping you do that by just plotting a line which you'll be able to use by just looking at the total miles driven, and then you check with the x-axis on how much, with the y-axis on how much is supposed to be paid. I mean, another area that linear regression can be used is prediction of whether a flight will be delayed or not, and very many other areas. Something else that machine learning can do is style transfer. Uh, most of you, I believe, have seen such. Most of you, I believe, have seen such. So this is style transfer. Basically, it's trying to create non-photorealistic images by combining various images. So as you can see, we have, this is the original image, this is the input. The first image is the input, and the second image is the style that you want for your input. And so your machine learning model generates a new image that tends has this style with it, and so that style transfer. Something else that machine learning can do is sequence prediction. I believe most of you have seen this in your when you're chatting. So it tries to predict what is the next word that you want to type. Also, Gmail has such a feature whereby it can generate some replies for you. It can generate some replies for you. So Gmail has such a feature which is also sequence prediction. Something else that machine learning can do, and this is in the autonomous world, self-driving vehicles. So basically, these are very many areas that have come together. So we have computer vision here. We have we have majorly computer vision is being used here, and this is an area where reinforcement learning is really used. So you need your vehicle to you need this vehicle to be able to identify where it should stop, where there's some traffic lights. It should identify the pedestrians. It should identify the lane that's supposed to run. So self-driving cars is an area where machine learning is used. If you didn't know that. Another area where machine learning is used, or what machine learning can do, I believe most of you have used the Google Translate app. So translating from one language to another, this is basically style transfer. And Google has a neural network for this. I think it's called neural transfer. Neural transfer. I'm not really sure about the name, but this is transfer learning, and this is machine. This is some of the things machine learning can do, or some of the areas where machine learning is used. Another area where machine learning is used is sentiment analysis. So most of you do use e-commerce websites, let's say Jumia or Amazon. So you buy your product, and then depending on how you felt, you go and comment. And I want you to imagine the number of people who purchase products from this platform. It might be very difficult to follow on the comments made by the people purchasing these products. And so machine learning can come in very handy in helping you categorize the comments of the reviews provided by the customers. So whether a comment is positive, neutral, or negative. So this is sentiment analysis, and basically it's in the field of machine learning called natural language processing, and it's very, very interesting. It's a very interesting area. It's also used in movie reviews, IMDb. So when you're reviewing movies, how movies are performed, machine learning comes in very handy in reviewing the sentiments of people. So you might be wondering now, where do I begin machine learning? Maybe just to make this clear, the extent of knowledge that you need to have in the machine learning field really depends on what you want to do, depending on how deep you want to go. So there are people who just want to use machine learning in their products. There are people who want to know machine learning because they work with software engineers or machine learning engineers. So it's good for them to understand so as to be maybe relevant. The people want to build machine learning libraries. So depending on that, that really defines on the extent that you should go in studying machine learning. And machine learning involves a lot of mathematics with itself, but not being very good in math or not being aware of this subject matter in machine learning should not hinder you from knowing machine learning, because that's for another group of people. Knowing mathematics is for a different set of people in the machine learning world. And so you should not be scared that maybe some of you have tried doing machine learning courses and you found some very difficult maths and you became scared and you quit. That should not scare you. That really depends on what you want to do, and I'll be showing you that in a while. So in finding knowledge or in trying to build machine learning models, actually, for those of you who have never coded before, or those of you who are not very familiar with the mathematical concepts of machine learning, you can build machine learning models without writing any code. So the image I'm displaying here is from Azure Machine Learning Studio. So you can this is a drag and drop platform for machine learning. So you just drag and drop, and you're able to build a machine learning model. So what you need here is just basic information, basic knowledge of machine learning, understanding the machine learning model, understanding the machine learning process flow. As you can see here, you have the data. You're gathering the data, you're exploring the data, preprocessing it, and then here you have chosen your model, a logistic regression model. Then you train your model, then you score it. It's evaluation. Yes, basically understanding the process of machine learning, and you're able to use such a platform. So the platform is called Azure Machine Learning Studio, and at your own free time, you can go and check it out. So for those who are interested in programming or those who are programming, so how can you get started with machine learning? So in machine learning, we have data analysis packages and core machine learning libraries. So for the data analysis packages, we have things like NumPy, which come in handy when you're dealing with arrays, because the normal Python list is not very efficient for doing mathematical computations. And so NumPy comes in handy. We also have pandas, which is very useful for maybe I would say tabular data. So pandas is also a very useful library for tabular data. Then we have matplotlib, which is a very good library for data visualization. We also have Seaborn, which is also a very good library for data visualization. So for core machine learning libraries, we have libraries like scikit-learn, we have TensorFlow, we have PyTorch, we have Theano, we have very many, but there are those common ones that we'll be looking in this session. So in this session, we'll talk about scikit-learn and TensorFlow. And those are some of the machine learning libraries that are available in the market, which are being used in some of the products you have in your phone or some of the apps you have in your phone. And so next, so as I mentioned, I'll be sharing a project that I worked on of face mark detection. And so if you're interested in looking at how the code works, that's the link to the GitHub repo over there. So you can just type that link somewhere, and then you'll be able to access the code that I'll be presenting in this session. So maybe just to give you a preview of what I'm talking about. So the machine learning model I built for face mark detection, this is it. Maybe I'll just give you a short preview of it. So the video has no sound, don't be worried. The video does not have any sound, it's just a video without audio. So as you can see, it's able to recognize when someone is wearing a mask and someone is not. So as per now, it's a bit buggy, it's not very efficient, but I'll be pushing more updates to it on the GitHub repo. So if you fork the repo, you'll be able to get the updates that I'll be pushing to it. So as you can see there was an issue and we're not able to detect. And that's what I'll be sharing. That's the machine learning model that I built. So maybe let's just go through the code very fast, and let's go through the code very fast. So let me share another screen. So I'll share another screen, and that's so this is the code that I used to build the model. So this file is also available in the GitHub repo. So this is Jupyter Notebooks. So maybe something that I forgot to mention is that machine learning requires a lot of computing power. And as you can see here, I'm using Jupyter Notebooks provided by Microsoft Azure. So there's a lot of computing power here. So you might be worried that you don't have a good laptop. So if you don't have a good laptop, you can just utilize such very useful online resources to build a machine learning model. So I'll quickly go through this notebook and try to describe some of the code. So as you can see, I've followed the machine learning process flow. So I gathered the data. So the data is available from a Google Drive that I've shared in the repo. So I'm extracting the data from this code over here. So all you need to understand this code is you need to have some understanding of Python. So you need to understand Python to follow up this code. So as you can see, I didn't have a lot of images. I have a very small data set. And here we can explore some of our data. So as I mentioned earlier, in the machine learning process flow, we have the process of preparing your data. And part of preparing your data, you'll realize later on as you're studying is that having very limited data compromises your machine learning model. And so we have something called data augmentation, which really helps in increasing your data set. So in this process, we are trying to view the data. So as you can see, that augmentation what has done, it tries to rotate the images, it flips the images, it zooms the images, it tries to do some transformation so as to a bit try to increase the data. And that augmentation is very useful to deal with overfitting, especially for those who have a very small data set. So basically here, I'm still preparing my data. So this is the training data, and this is the validation data. So as you can see, the goal of my model here is to classify whether an image is a mask or not. So this is binary classification. As you can see here, it's binary. So we have two classes, mask or no mask. And then here I'm adding dropout regularization. The dropout regularization also helps in dealing with overfitting. So what dropout regularization does is that it drops some of the features. It drops some of the features that your machine learning model has done, so that it doesn't generalize on what it has used, and that's very useful to deal with overfitting. So here I'm compiling the model, and as you can see, the laws that I've given here is binary cross entropy. So if you're dealing with two classes, for my case, mask and no mask, the best one to work with is binary cross entropy. If you're dealing with a multi-class model, what you need to use is categorical cross entropy. And these are some of the variables that are passed. This is the learning rate. So the learning rate is also very useful. When you put a very high learning rate, it will really affect your model, and will not. For those of you who might try to go deeper, you'll realize that it really affects the gradient descent. In this case, we're using RMS crop. We're not using SHD, the stochastic gradient descent. So it really affects. So the learning rate is very useful. So this is the model summary of the model we have built. So it has the input layer, which takes images of 150 by 150 by 3. Then this is the first convolutional. This is the first hidden layer. Then we have a max pooling. Basically, this one tries to reduce the number of features from your model. And then we have the conv2d, which also is all about getting the right features. Max pooling, try to reduce the features. So in flattening here, we are trying to get a connected network. And then we have the dense layer, the dropout layer, and then the output layer, which is a sigmoid layer. As you can see here, it's a sigmoid layer. So the sigmoid activation function is very useful when you're dealing with a binary classification. You can also use softmax for that, but softmax comes in handy for categorical classification. So here we are training our model, and I decided to train it for 30 epochs. So this is the part that really consumes computing power. And depending on your goals, you may need to tweak the number of epochs that you're training your model for. And so in this case, I decided to train it for 30 epochs, each with 62 steps. So these are some of the metrics that are being provided. And it's very important to understand these metrics, because understanding these metrics, the loss, the accuracy, the validation loss, and the validation accuracy, can really help you identify whether your model is underfitting or it's overfitting. For instance, one good way to understand whether your model is overfitting is you might realize that your validation accuracy is increasing, or it's almost leveling, or it's almost reaching a constant point, but the loss here, the training loss, is continuously reducing, even if your validation accuracy has leveled or is increasing. So that's one very important way to understand whether your model is overfitting. So it's very important to understand these metrics. So model evaluation is very important also to find out how your model is performing. And there are very many ways to evaluate your model, and you shouldn't really depend on one, because each way of evaluating your model has its own pros and cons. So here we are looking at the training and the validation accuracy curves. And here we have the confusion matrix, which is also known as the error matrix, which is also very useful, provides very useful metrics for your model. So it's basically, this is the plot of it. So you'll realize you have something like true positive, true negative, false positive, and false negative in the confusion matrix. Then we have the classification report over here. So it gives you some metrics about how your model is performing. So depending on your interest with your model, either of these might be very important to you. So we have the ROC curve. So the ROC curve is from the ROC curve, we're able to find the AUC, which is area under the curve. So it's a very important metric in machine learning. And also the ROC curve comes in handy when you're trying to find the optimal probability cutoff for your machine learning model, because you'll realize as we go through this Jupyter file, this notebook file, that we used a cutoff point of 0.5, which is not really the case. You need to find out which is the best optimal cutoff point for your machine learning model, and I'll be doing that later on. So for those who will be following, for those who will fork this GitHub repo, you'll be able to find the updates. And so once you're done with your machine learning model, you can save it. There are various formats in which you can save your machine learning model. So I decided to save it in the HDF5 format. So you can save your machine learning model in this format. And from here now, you can use your machine learning model. So for example, here now, I'm using the machine learning model to detect whether an image has a mask or not. So I'm using OpenCV and Matplotlib here. So, and I'm also, as you can see, I'm using OpenCV, the cascade classifier, to detect faces from an image, from which I pass those faces to my machine learning model, which can now predict whether my image has a mask or not. And so these are some of the predictions it can make. As you can see here, it says this person has no mask. And if you run a different image, you'll also be able to see that it will draw a green rectangle of this person of someone who's wearing a mask having a mask. Yeah, and that's all about this notebook file. So just to proceed from where we were. So that's all. That's the introduction we'll give for machine learning. And if you have any questions, or if you've been interested in finding more about this, we can talk more. That's my contact information. So let me just head over to the last slide. I'll also be sharing these slides later on. And this video will also be uploaded to YouTube. So yeah, that's all about machine learning. Thank you very much. And yeah, it was a pleasure sharing my knowledge on machine learning.